Okay, welcome to a continuation of the stem and leaf plots. We are going to keep working on looking at the back-to-back stem and leaf plot. So we looked at this definition in class, and that a back-to-back stem and leaf is used to compare two sets of data, and it can be either rounded or truncated or just two separate sets. And we looked a little bit about this chart. So this one was a listing of the average annual pay for workers in selected states. And so we have each state, and we have some average annual pay. And if we look at it, we are noticing that we have a 5-digit number. And a couple of things we talked about is we talked about that the stem can have more than one digit, but the leaf can always only have one. So if we look at this data, and we would take the ones digit every time and attempt to make a stem and leaf graph with this as our stem and that is our leaf, we would end up with way too many stems because we would have to have 21472, 2148, 2149, 2150, and you can see that not all of those numbers are represented in our data. So when you have numbers with very large values, that's when we start either rounding or truncating those problems. So let's take a look at this. We're going to go back and kind of look at it. So one problem with doing the stem and leaf traditionally is if our leaf is 3 and we identified our stem, we could also not have a stem of 2. We couldn't have a stem of 28. Or if we tried that and we started at our lowest 10,000 would be 21. 22, 23, 24, and went on that way, we can't have 472 as a leaf. It doesn't work that way. We talked about that. Our leaves can only have one digit. All right, so that's why this does not work to do it this way. So this is when we're going to look at rounding and truncating data. Let's go on to the next piece. So here I took some of the data and I expanded it out. So we're going to practice rounding and we're going to practice truncating the data. Now before we round or truncate, we want to determine what place we are going to round or truncate to, with the understanding that our stem is going to be 1 or 2 digits. Well, let's say we want our stems to be just 1 digit. So if we take a look at this and we went with the farthest digit to the left, we would have a 2, a 2, a 2, a 2, 2, 2, 2, and 2. Well, that's not going to work very well for a stem. We're not going to be able to distinguish much data if they all start with a 2, because then the next letter, or the next number, is always our leaf. So let's look at the first 2 digits. We have 28, 24, 21, 26, 24, 21, 25, 26. That looks like it makes sense. That makes sense for what we've done with our stem and leaf plot. So let's start by writing in our stem, starting with the lowest one. Here we have 21. And we know that in here, 21 equals 10 thousandths. So here we might want to write 10 thousandths. Okay? 20, then it'd be, and our largest is 28. So we know we'd go 22, 23, 24, 25, 26, 27, and 28. Now we need to do our leaves. Now remember, we talked about 2 ways to do this. We can do our stem and leaf truncated, or we can do our stem and leaf rounded. Rounded, remember, is we round. And because we are rounding to the thousandths place, or we are stemming to the thousandths place, we are going to round to the thousandths place. So if we have 28,033 rounded, we're going to round it to 28, 0. 24,126 rounded is going to be 24. Oh, I just realized I did something wrong. We're rounding to the nearest hundredths place. So 3 rounds back to 0. 24,1 is going to go to 24,0. So here we have 21, is our stem. We have our 4 would be our leaf, but we have a 7. 7 is going to round up to 21.5. Here we have 26. 2 is what we're rounding to. 3 is our next number. 3 is lower than 5, so we're going to keep it at 2. We go over here. We have 24. 1. We have a 9 next to the 1. That's going to round up to 24.2. 21. Got our 4. 8 next to it. That's going to round up to 21.5. 25. We have a 7 next to a 4. That's going to stay at 25.7. And here we have 26. We have a 3 and a 4. 4 goes down. So that's going to be 26.3. So that's rounding. In this one, we rounded to our nearest hundreds place, because that's the leaf. The leaf is represented in the hundreds. And so we rounded to that nearest hundreds place. Now we're going to truncate. Remember, truncate means we're just going to cut it off. So when we truncate, we know that our 10,000ths place is our stem. We know that this is our hundreds. And I'm going to write the hundreds place in each of them. And we're going to truncate at the hundreds. So we find our hundreds place. We draw a line. So it's 28.0. On this one, we have our hundreds place. We draw a line. It's 24.1. Draw a line. 21.4. Draw our line, 26.2. Draw a truncating line, 24.1, 21.4, 25.7, 26.3. Now we have two pieces of data. On this side, we have our data rounded. On this side, we have our data truncated. So let's fill it in. Rounded goes on the left. So if I go down here, I have 28.0. So I'm going to find my 28, and I'm going to put a 0. There I have 24.0. I'm going to try and find my 24 and put a 0. 21.5. I'm going to put a 5. 26.2. 2 under 26. 24.2. I'm going to put a 2. 21.5. Another 5. 25.7. 26.3. And you would keep going on with your data, filling in your leaves for the rounded. Now we go to the truncated. It's 28.0, so we're going to have a 0. 24.1, we're going to have a 1. 21.4. 26.2. 24.1. 21.4. 25.7. And 26.3. And so we have our data both rounded and truncated. All right, so if we look at this, this is all of the data from all the original states. And we have it both rounded and we have it truncated. So on the left is the data with it rounded to the nearest hundreds, and the right is it truncated to the nearest hundreds. Okay? So that's how it looks if you do the whole chart. All right. So I want you to answer this question. What does 2,1/5 represent in each plot? Think about that, what 2,1/5 would represent on each side. Write that down, and then check your answer. All right, so if you look at it, what it's representing is any number from 21,450 to 21,549 for rounded data. So the 21.5 is representing actually a range of data, because it's representing what the lowest possible number would be to still round it up to 21.5, and the highest possible number to round it to 21.5. And then truncated is 21,500 to 21,599, because if you truncated either of those numbers, you would get 21.5. What's the difference between the highest and lowest average annual pay? So on this one, you're finding the difference between the highest average pay and the lowest average pay. Go ahead and find that, and then check your answer. You'll want to pause the video. Okay, so what we did here, we have about 6,900 for rounded data and about 7,000 for truncated data. So let's see where they got that from. So if we look at that, the lowest average pay would be 21 because it's our lowest stem. And we go to rounded. Our lowest leaf is 2,100. Our highest, 28 is the stem, is the highest. 28,000, take away 21,000 equals 6,900. So that's where we find the difference there. And for the truncated, our lowest is 21,000. Our highest is 28,000. You find the difference there, and it's $7,000 difference. So you still find the highest and lowest the same way. And as you can tell with our rounded and truncated, we don't have that much of a difference. All right, so did more or half of the states have an average annual pay above or below $25,000? So I want you to pause, put your answer down, and then compare it with what the answer is. Okay, the answer is below. So what you would do here is find the 25,000. So right here we have it represented with 25,007, or the stem of 25, and the leaf of 7. So it's more or below? Well, above, it's 1, 2, 3, 4. People paid more than that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 people paid below that. So you can still use this data in the exact same way. Does there appear to be any significant difference between the two stem and leaf plots? So when we're looking at the rounded stem and leaf versus the truncated stem and leaf, are you seeing any differences? So take a second to look at that, pause the video, come back and check what your answer is. The answer is no. You can see that there's the same amount of data points in each leaf connected to every stem, with the exception of right here, there's another 0. And on this one, there's one more data point on this side. But that's pretty insignificant. So no, there's not that big of a difference in the data when you truncate it around it. All right, so here we have another problem. It says the enrollments of several small colleges in the Center City area are listed below. Make a back-to-back stem and leaf plot of the enrollments, comparing the rounded values versus the truncated values. And then you're going to answer each question. So I want you to pause the video here. I want you to get out a piece of paper, and I want you to make a back-to-back stem and leaf plot of the enrollments. So start with that, and then when you're finished with that, come back to the video, and then answer the questions. Okay. So we're going to look at what your stem and leaf should look like. So the first thing you should have done is taken a look at your numbers here. Okay? And looked at the farthest left first to see what differences you have, and then decided where you're going to make your stem and where you're going to make your leaf. So looking at this, you'll see that because the data ranged from 1,013 to 3,780, we use the stems represented by the thousands place. And so we made a stem for the 1,000s, the 2,000s, and the 3,000s. And then based on the rounded data, got these leaves and these leaves. So check your graph versus this to see if we have the same information. All right, first question. What range of student enrollment is represented on the rounded side by 2, 4? So what is the range of student enrollment? If you don't remember what that means, you need to go back in the video to when we talked about the range off the other stem and leaf plot. All right, so you're going to want to pause the video briefly, answer the question, and come back. Okay, your answer should have been between 2,350 and 2,449. Next question. What range of student enrollment is represented by the truncated side by 1, 9? This is the same type of question. Go back in the video if you can't remember. Pause your video and then come back and check your answer. And you should have had between 1,900 and 1,999. So since each stem represents 1,000, 3/8 represents all the numbers between 3,000 and 399 because otherwise, because you truncate right at the thousands point. And that's it. Bring any questions you have to school tomorrow and we'll work on answering them. Have a good night.